back to my tutorial. Today, we will going to see the second part of chapter 4 of Introduction to Emerging Technology, which will be discussed about the Internet of the Things. So, in this first part, we will going to see challenges of IoT, and also we will see how does IoT work. And finally, we will see the architecture of IoT. But for the students who didn't see my first part of the chapter 4, in the first part of the chapter 4, we have seen an overview of IoT, and we have seen the features of the IoT, and also we have seen the different definitions that has been given for the Internet of Things by the different organizations. And also we have seen the history of the IoT, and the advantages and disadvantages of IoT has been seen. I recommend you, for the students who didn't have seen the first part of the chapter 4, go through my video and visit the first part and then come back to this part. Barattoota warra paartii lamaffaa kana hin arginii fi paartii jalqabaa chapter arfaffaa overview IoT ilaallee turre, featureota isaanii ilaallee turre, hiikaa IoT dhaabbanni garaagaraa kennaafi turre ilaallee turre, seenaa IoT ilaallee turre, akkasumas immoo faayidaa isaatii fi miidhaa isaa ilaallee turre jechuudha. Today we will going to see this second part. The first point that we're going to focus on is about the challenges of the IoT. Challenges of IoT. What kind of challenges are there? What kind of challenges we will face if we deploy such like applications of Internet of Things in our organization? The first issue is the issue of security. The issue of the security. IoT creates an ecosystem of the constantly connected devices communicating over the networks. So as we have said in the first part, as a number of interconnected number of devices increase, then the flow of the information also increases, which paves the way for the hackers in order to hack the confidential or sensitive information of one particular organization. So the system offers little control despite any security measure. This leaves users exposed to various kinds of the attacks. So, akkuma sila duraan jenne security ni dhimma guddaa xiyyeeffannaa guddaa barbaadu challenge IoT keessatti jechuudha. Akkuma deviceonni interconnected ta'an increase ta'an confidential information data flow achi keessa jiru information flow achi keessa jiru waan dabaluu fi hackerootaaf confidential information yookiin security information yookiin confidential information kaampaana tokko haxuuf haala mijeessaa jechuudha. Kun challenge IoT fayyadamuuti yookaan disadvantage IoT jechuu dandeenya. The second one is the issue of the privacy. The issue of the privacy. The sophistication of IoT provides substantial personal data in extreme digital without the user's active participation. Maybe such like sophisticated information which will be revealed for the third party, which may be damaged by the third party if it is revealed for the others. So the issue of the privacy may not be protected if the such-like application of the Internet of Things will be launched in one particular organization. Privacy imma abbumma substantial personal data. Substantial personal data may be revealed, may be exposed for others when we use the IoT. This is the second challenge of using IoT. The second one is the issue of the complexity. The issue of complexity. Some find IoT system complicated in terms of the design. It's very complex in order to design, to deployment, and also maintenance, given the use of multiple technologies and large set of new enabling technology. And maybe in order to design, in order to maintain and or to deploy by interconnecting different number of the devices which may share the data among themselves by using the different number of sensors, by collecting the data from the environment, and finally, in order to give the decisions, maybe complex in case of designing and in case of deploying, as well as in case of the maintenance during system failure. Complex jechuudha. IoT device kun fakkeenyaaf amma deviceota akkanaa kanneen dhaabbata tokko keessatti yookiin dhimma tokkoof jira oolchuudhaaf diizaayinii isaatiin jalqabee deployment wal qabatee maintenance dhaan wal qabatee siruu yeroo system fail ta'u challenge guddaadha jechuudha. Another one is the issue of the flexibility. Many are concerned about the flexibility of the IoT system to integrate easily with another. They worry about finding themselves with several conflicting or locking the system. The issue of the flexibility of the systems of the devices participated in IoT interconnections. Maybe another challenge is to apply such like technology or to launch such like technology for one particular organizations or for one particular firms. Another one is the issue of compliance. IoT, like any other technology in the realm of the business, must comply with the regulations. Its complexity makes the issue of the compliance seems incredibly challenging when money considers standard software compliance. But first, the issue of the compliance, when we want to deploy the Internet of the Things for an organization, for one particular company, it should have to come up with the rules and regulations to obey the rule and regulation of one particular organization, unless the issue of the compliance is another issue. So how does IoT work? So how can such like a systems work, or how it works? IoT ecosystem that consists the IoT ecosystem consists web-enabled smart devices. The very small number of smart devices may participate in IoT, which is web-enabled devices, which uses embedded processors, embedded sensors, and communication hardware to collect, send, and act on the data they has been acquired from the environment by using different number of sensors. So such like IoT devices works by combining together the smart devices combined together by using different number of processors, by using different number of sensors, by using different number of communication hardwares in order to collect the data, to send the data, act on the data acquired from the environment in order to make a decision. Akkamitti akka hojjetu fakkeenyaaf maalinni IoT ecosystemiin web enabled smart device of keessaa qabu. Kan maal of keessaa qabu, kan processor of keessaa qabu, sensorii garaagaraa of keessaa qabu, communication hardware kan of keessaa qabu, data collect gochuudhaaf, data send gochuudhaaf, akkasumas immoo data san irratti act gochuudhaaf, decision barbaachisu decide gochuudhaaf haala kanaan hojjetaa jechuudha. So these IoT devices share the sensors data. They have collected, they collect by connecting to the IoT gateways or another edge devices where data is either sent to the cloud to be analyzed or analyzed locally. The data that has been collected by the using sensors may be sent to the cloud, or it also can be analyzed by the local data, by local devices, by saving on a local storage devices, such like the collected data can be analyzed for the for decision making, for for the purpose it has been intended for. The device do most of the work without human intervention. So the devices that are participated in this Internet of Things able to collect, able to send, able to share, and able to analyze the data without any human intervention. No need to intervene such like a device. If it is Internet of Things, they should have to be autonomous devices. They are devices which are able to work by themselves, by collecting the information from the data, by using a different number of sensors, then finally analyze the data in order to make a decisions. Then finally the action will be taken by using different number of actuators. For example, for instance, to set them up, give them instructions or access the data. So the connectivity, networking, and communication protocols used with these web-enabled devices largely depend on the specific IoT application deployed. So each and every device is needed for this IoT deployment should have to be based on their specifications. So the another one is about the architecture of IoT, the general architecture. Generally, IoT device can be so IoT devices can be explained as a network of the things, that consists hardware, that consists the software, network connectivity, what we have said in the part 1, communication channel, and a different number of the sensors. Generally, this architecture or architecture of IoT comprises 4 number of layers. The first one is application layer, the second one is network layer, the third one is data processing layer, and the fourth one is application layer. Architecture of IoT kun maal of keessaa qaba? Network of keessaa qaba, hardware of keessaa qaba, software of keessaa qaba, network connectivity isa chapter party tokkoffaa keessa dubbanna, communication channel of keessaa qaba. It also contains different number of the sensors. Generally, this architecture of IoT architecture comprises or contains 4 number of sensing layer. The first one is sensing layer, lamaffaan network layer, arfaffaan data processing layer, arfaffaan immoo sadaffaan data processing layer. The first one is application layer. Let me see each of them in turn. The first one is sensing layer. What is the advantage of sensing layer? We have said many things in part 1 of the chapter 4. The main purpose of this sensing layer is to identify any phenomena. The main purpose of sensing layer is to identify any phenomena. So any phenomena in the device's peripheral and obtain the data from the real world. They are able to sense different number of sensing layers, sensing materials. Sensors are able to sense their environment. Then by tracking the environment, the information, what is going on in the environment, by using different number of sensors, collect the data and also send that collected data for the different number of data analyzing layer in order to analyze it. So its main purpose is to identify what kind of phenomena is going on in the environment, in the device or in the device's peripheral, and also obtain such like the real-time data from the real world. So such like sensing layers are contain several number of sensors. Sensing layer contain different number of sensors. It's contained, there are many types of sensors. So using multiple sensors for application is one of the primary features of IoT. Using different number of sensors. If there is no sensor, there is no IoT. As the human being, we have the different number of different number of, as a human, we have different number of organs in order to detect each and every factors which is happening in the environment. The same is true for Internet of Things in order to sense what kind of phenomena is going on in the environment by using a different number of several different number of sensors. So sensors in IoT devices are usually integrated through different number of hubs. These different number of hubs are used to connect different number of sensors together. Sensors hub is common connection point for multiple number of sensors. So, BTech, if you are a freshman student, this sensor hub, maybe it will maybe come on your final examination or your mid exam. So the main advantage of sensor hub is used to connect different number of sensors. For example, when we want to launch such like in IoT for one particular different number of for one particular purposes for an organizations, we may use different multiple number of sensors. Those multiple number of sensors should have to be connected together. In order to share the data, they are extract or track from the environment. So this sensors hub is used to connect those number of sensors together. Malini, that sensors are accumulate and also forward sensors data to processing unit of the devices. So sensor layer kun maalif nu gargaara data naannoo irra jiru sense gochuudhaaf data naannoo irra jiru collect gochuudhaaf nu gargaara jechuudha. Kanaafuu sensor hubbiin maaliin faayidaa isaa? Sensor hubbiin sensoroota garaagaraa wal quunnamsiisuudhaaf sensoroonni garaagaraa akka wal horgatan. IoT tokko fakkeenyaaf dhaabbata tokkoof gaafa launch deploy gochuu barbaannu sensoroota garaagaraa nu barbaada. Sensoroonni garaagaraa sunni wal argatuu qabu, walitti connected ta'uu qabu, data share gochuudhaaf, waliin hojjechuudhaaf. Kanaafuu sensor hubbii it is a common connection point for multiple different number of sensors jechuu dandeenya jechuudha. So another point in these sensors are actuators. This actuator can also intervene to change the physical condition. It is used to change the physical condition of the objects. Physical condition of the object according to the data that has been tracked by different number of sensors. So an actuator might, for example, it may shut off the power supply. Actuator may enforce our IoT to be shut down the power supply, or it may be adjust the airflow valve or move robotic gripper in an assembly process. It may enforce our IoT devices in order to do certain actions based on the data that has been extracted or collected by different number of sensors. Maal nu gargaara actuatoron kunniin maal nu gargaaru wantoonni suni autonomously without human intervention adonam intervening godhini dalagaa kasaan dalagan. Fakkeenyaaf amma power IoT smart home yoo qaban suppose that smart home yoo qabaanne galgala gaafa sa'aatiin manni keenya dukkanaa'uuf jedhu balbiin akka ifu. Kan balbiin akka ifu san power on godhu maalinni actuatorii. Dukkanti dhufu suni daataadha. Daataan dukkanaa gaafa argatu maan godha actuatorri ofiisaa power switch on godha jechuudha. Yommuu latti bariitu switch ifa sana maal godha off godha jechuudha. Akka isaa on akka isaan device keenya dalagu hojii sila namni godhu akka hin goone akka device ofiisaanitti act godhanuuf kan gargaaru maalidha? Actuatoridha jechuudha. IoT device keessatti. Is it clear? So these sensing layers, in this sensing layer, there are different number of sensors. For sensors, there are different number of sensors types are said. We have motion sensors, and also we have another environmental sensors, but the third one is position sensors. We have three different types of sensing layers. In this sensing layer, we have three types of the sensing layer. Motion sensors are there, environmental sensor, and position sensor. That we see each of them in turn. So what's the advantage of motion sensors? If it's a motion sensors, if we have a motion sensor in our devices, what kind of activity or what kind of phenomena it will going to be sensed. So such like a motion sensor. Motion sensors are measure the change in the change in the motion, as well as also it's used to sense the orientation of the devices. Changing motion to device to keessa jiru. Changing motion to keessa jiru. Akkasumas immoo orientation device tokko since gochuudhaaf kan gargaaru motion sensory. Motion sensors. Basically, there are two types of motions. The first one is linear motion and the angular motion. Linear motion and angular motion. Whether it's a linear motion or angular motion, such like motions are sensed by using motion sensors. So the linear motion refers to linear in displacement. Linear in displacement for an IoT device, while others are angular motion. Refers to rotational displacement of the devices. Is it clear, guys? Motion sensor kan jennu sensorota change in motion. Jijjirama motionii sochii keessaa jijjirama sochii tokko kan measure gochuuf gargaaru. Basically sochiin bakka guddaa lamatti qoodama. Sochii kallattii sirrii irraa fi sochii martoo kan jennu. Sochii kallattii linear displacement yoo ta'u sochiin kallattii linear displacement device ka device ita hasara bazawe kan IoT device akkasumas immoo rotational displacement of the device wantoon ifirra kan gargara yoo ta'e rotational displacement of the device inna device on kallattii tokkorra kan deema ite immoo linear displacement motion jechuun dandeenya jechuudha motion akkana kan ammoo sense kan godhu motion sensor. The another one is about environmental sensors of the sensing layer. Environmental sensor. Environmental sensoring basically the environmental sensors are used to sense different number of lights, pressure, in order to sense changing in the environment, parameters in the device pressure. Sensors such as light sensor, pressure sensor, etc. are embedded in IoT devices, are included in IoT, built within IoT in order to sense the change in the environmental parameters in the device's peripheral. In order to sense light of the environment, in order to sense the pressure of the environment, and in order to extract, in order to track such like change in the environment, and such like environmental sensors are playing fundamental role. The primary purpose of these environmental sensors in IoT devices is to help the devices to take autonomous decision according to the change of the device's peripheral. If the change is needed, according to the data that has been collected from those different number of sectors or different number of sensors, then environmental change in action means decision will be taken by the IoT devices themselves. So for instance, for example, environmental sensors are used in many applications to improve a user experience. For example, if you consider the home automation system for a smart lock and smart light, these are environmental sensors which we can apply, we can change into the actions like home automation system, a smart lock and a smart light into automation by using environmental sensors. For example, yoo fudhatan mana keenya yoo fudhatan laayitii mana keenya keessa jiru akkasumas immoo manni keenya gaafa nuti alaa dhufu ofiisaa akka banee gaafa nuti gara keessa seenu ofiisaa akka cufu akkasumas immoo balbii ofiisaa akka ifu gaafa dukkan dhufu ofiisaa akka ifu gaafa ifu ofiisaa akka badu. So isa kanin launch gochuudhaaf IoT kasii hojjechuudhaaf environmental sensory fayyadamna jechuudha. Another one is position sensors. Position sensor. Those position sensors of IoT device deal with physical position and location of the devices. Most of the time, this position sensors deals about the physical position and location of the devices of IoT. If our devices, IoT device contains such like position sensors, they automatically, if we are managing such like a device by using endpoint management device, we are able to know the physical position, in what physical position the devices are there, and also the location where our devices are located. We can know by using such like a different number of position sensors. The most common position sensors, there are also most common position sensors currently all over the world. The first one is magnetic sensors. This magnetic sensor is used to detect the magnetic field of the devices and also a global positioning system, GPS, in order to indicate the location of the devices. These magnetic sensors are usually used as a digital compass. They are used to use as a digital compass. The main function of GPS in order to indicate the position, the physical location of the object is the physical location of the object. Position sensor on kunni maal kun gargaara physical position if location of device uta bakka device into argam physical location isa. So common position sensor kan jennu kan akka magnetic sensor. Magnetic sensor kun magnetic field yookaan immoo akka magnetic sensor kun akka digital compass itti gargaaru. Magnetic sense and global positioning system kan jennu GPS kun maal nu gargaara physical location of object eessatti argaman. Fakkeenyaaf konkolaataan keenya. Fakkeenyaaf as teenne mana keenya teenne konkolaataa keenya mana jigoona yoo ta'e konkolaataan kana GPS qaba yoo ta'e information karaa silkii keenyaatiin kan wal jijjiiratu yoo ta'e iddoo konkolaataan keenya itti argamu physical position isaa hunda mana keenya teenne control gochuu dandeenya. So these position sensors are used to detect or sense the physical position as well as the location of the objects. So another one is the network layer, the network layers. This network layer, as we have discussed it before in the first part of the chapter 4, it's a communication channel. It's a communication channel. Network acts as, this network layer acts as a communication channel. Communication channel in order to transfer the collected data in the sensing layer to other connected devices. So in order to communicate each and every connected device within each other by using different number of sensors, this network layer is very important. If there is no network layer, there is no communication among the smart devices. So in IoT devices, this network layer is implemented by using different communication technology. So by using this different communication technology, we can make our devices can able to communicate each other. So this diverse communication channel may contain Wi-Fi, Bluetooth, Zigbee, web, LoRa, cellular network. These are a communication channel which paves the way our smart devices to communicate within each other. Network layering kun maal nu gargaara akka communication channel data transfer gochuudhaaf data collect gochuudhaaf even data collected isa sana transfer gochuudhaaf wal jijjiiruudhaaf process godhuudhaaf maaliif network layering kun nu barbaachisa jechuudha. IoT device keessatti network layer is implemented by using diverse communication channel. So IoT keessatti network layering kuni kan ittiin launch ta'u kan ittiin deploy ta'u communication technology garagaraa fayyadamuudha. Fakkeenyaaf Wi-Fi fayyadamuudha, Bluetooth fayyadamuudha yookaan cellular network fayyadamuudhaan akkasumas network layer kana IoT keessatti build gochuu dandeenya jechuudha. Akka deviceoon kan keenya data collect godhan sana waliif share gochuu akka danda'an. The other one data processing layer. So as a human mind, the information that we sense from the environment throughout the physical organ. So for the IoT, they should have to have such like a processing layer. As a human mind, We may sense the information, we may receive the stimulus from the environment. Then our minds are processed that received information and also give the actions for that particular stimulus. The same is true for IoT devices. Whatever information is collected or extracted or tracked from the environment, they are able to be processed. The data processing layer consists of the main data processing unit of the IoT. The data processing unit in IoT is used to process the data that has been collected by IoT devices by using it through different number of the sensors. The data processing layer takes the data collected in the sensing layer and analyzes the data to make the decision based on the result. So the data processing layer also saves the result. The main purpose of the data processing layer is not only data processing. It also used to save the previous result in order to improve their future experiences. So the data that has been the analyzed previously will be saved by these data processing layers in order to increase their future experiences, in order to make a good decision. Another one is the application layer. This is just the user-centered layer. It's known as to be user-centered layer. User-centered layer. Don't forget that. From the following, you may be asked in such a way. From the following, which one is known as to be user-centered layer of IoT? So you should have to be able to answer this. Application layer is the end layer. The end layer which will be display the result for the user, for the end actions. So it is a user-centered layer that can execute various tasks for the users. So the application layer implements and presents the result of the data processing layer to accomplish this disparate application of IoT devices. The application layer is user-centered layers that execute various tasks for the end users. This exists diverse of IoT applications, which include maybe through this application layer can be seen through the smart transportations, a smart home, and personal care and health care. The last one is the architecture of the IoT in graphically. As we have seen, in this architecture of the IoT, there are four number of layers. The first one is sensing layer. In this sensing layer, we may have different number of sensors, guys. Different number of sensors. These are different number of sensors. For example, this GPS is another number of sensors. This is also voice recognition. This is also what this. Different number of sensors are there. These different number of sensors are known as to be sensing layer. If the data is collected from the environment by using these different number of sensors, then it will be transferred into the processing unit by using network layer, by using communication channel. This communication channel may contain Bluetooth, Wi-Fi, different cellular network, and different. This in general, it is known as to be a gateway. This network layer is a gateway. The gateway through which the collected data is transferred from the sensor to processing unit. So the third one is the processing unit, guys. This processing unit receives the data from the sensor through this gateway, through this network communication channel, in order to process it. As a CPU is one of central processing unit which are able to process the collected data from the environment by using different number of sensors. Then finally, we have an application layer, which is user-centered interface, user-centered application. We may have different number of smartphones, we may have a smart car, we may have various different number of devices through which the end result can be displayed for the end users. Guys, this brings us to the end of our today's lesson. Thank you for watching. If you have questions, please don't hesitate to comment include under this YouTube, under this video, and I will also include for this material I have included here under the descriptions the module that has been prepared for you by being together by collaboration of the three number of universities. And I would like to say thanks to you. Please don't hesitate to like, to subscribe, and to share your friends. Thank you. Bye bye.